All right, we're ready, Tom. Our first keynote this morning is Dr. Tom Drake from the Office of Navy Research. If you don't mind me embarrassing Tom just a little bit here, I'm a retired Navy guy. There's a few of you in the audience that are. And those of you that served in the fleet will appreciate what Tom's office continues to do to support the fleet. It's the battle space, as we call it, of characterizing the battle space, top of the atmosphere, bottom of the ocean, the basic research that goes into the models and algorithms, the databases that put bombs on target, that support our sailors at sea. I've been an admirer, Tom, of your code even before you were there, but we certainly appreciate it. But the other thing is the support from your office in the student poster competition. My goodness. I think since the mid to late 80s, but the fact that you spend those valuable dollars to support our youth in these in this field of marine science. Thank you. Without further ado, Tom, the floor is yours. Thank you so much.
Quite a bit of time talking about a whole of government, public partnership approach that's embodied in the National Oceanographic Partnership Program. But before I get ahead of myself here, I borrowed the Admiral's slide deck. I've only got one of his slides for you, and it's this one right here. And it mentions the fact that ONR was stood up in 1946 to preserve national security. And climate change and its impact on our coastal environments, not to mention everything else to do with the oceans, is a matter of national security. So while we tend not to look at things that have long time scales like sea level rise, subsidence, and processes like that, we're very interested in the environment, not only around the United States, but all over the world, and in our ability to predict that environment wherever we may need to go, whenever we need to go. So we're working on several things at ONR. I noticed this picture of President Truman there indicates that we continue to need to work on our diversity, but we'll keep working on that. So I'm not going to give you a huge overview of ONR. We have 5 departments. We're about a $2.5 billion organization per year, run by a 2-star admiral, Admiral Selby. We have 5 departments. One of the departments is the one that I own. It's the Ocean Battle Space Sensing Department. I'm going to run you through a little bit of what we do here. Like Ray mentioned, we start up in space. We study the ionosphere. We study that boundary between the fuzzy boundary between the ionosphere and the rest of the atmosphere. We take that right down to sea level. We're very interested in air-sea interactions, which of course impact the Navy as well as all the things that we'll be talking about with coastal resilience this week. I put littoral geosciences kind of in big letters there. So our main customers there are the Marine Corps and Naval Special Warfare, who go across the shore. And then we get beneath the water surface, physical oceanography, the full water column all the way down to the seabed, and beneath it, because what's underneath the seabed is of great importance to our submariners. To finish things out, kind of on the research side, ocean acoustics is one of the areas that we specialize in. NNR stands for National Naval Responsibility. We're the only federal agency, although that's starting to change, that funds ocean acoustics. It's a major program for us, tens of millions of dollars each year put into it. And then we have a marine mammals and biology program that is focused on safeguarding marine mammals and ensuring that the Navy is able to train and operate without harming marine mammals. So on the right-hand side of this diagram are the applications. I'm not going to spend much time talking about those, but you will hear about those from Marty Irvine when he talks. So anti-submarine warfare, mine warfare, undersea signal processing. I'll stop a little bit on the unmanned systems. So most of the gliders and powered uncrewed undersea vehicles had their origins in Code 32, my department. Much of that work was done before I arrived, and much of it was done by people in this room. That's been a 30-plus year journey. We're still working hard to put those things in the hands of the Navy, but it's difficult, as all of you know, to put operational vehicles that are robust and resilient into the water. So that's a continuing effort for us. Supported by our research facilities, my department has 6 ocean-going research vessels. We operate all over the world in areas of naval importance to look at scientific problems. So for example, we're looking at stratification and rapid changes of stratification up in the GI-UK gap. That's an area of great importance to us these days. We spent more than a decade in the Western Pacific working with a number of countries there, Taiwan, the Philippines, Vietnam, Indonesia, among others. So we pride ourselves on working around the world on problems of naval interest. Okay, now I want to move into the topic that, of interest, and that is coastal resilience. So ONR has not focused a great deal of attention on coastal resilience per se over the years. We've invested a great deal in understanding coastal processes. In fact, when I came to ONR almost 20 years ago now, I took over the Coastal Dynamics program, and that program was focused on water of a depth where I could touch the bottom in one breath. And I used to say that the majority of my money was spent in water that was about 2 meters deep. So I've expanded my realm much beyond that lately, but the problems of the coast haven't gone away. We have a pretty good understanding of nearshore processes on sandy coastlines. We have a reasonable understanding of muddy coastlines. We are just now starting some work to look at rocky shorelines, a program run by Reggie Beach, who incidentally is also the manager of ONR's National Oceanographic Partnership Program. The coastal processes, we've looked at those short-term processes, again, to support our customers, the Marine Corps and Naval Special Warfare. But these longer-term processes are the ones that are really biting us now. And this slide kind of shows a general picture of a place, and you can imagine that might be a Miami, or a Norfolk, or a Manila, or Jakarta, and you'll see Jakarta here in a little bit. And the problems that we need to address are not only sea level rise, but also the processes of removing groundwater and sometimes energy resources that can increase the rate of subsidence. There's natural subsidence. For example, the Mekong River Delta is only about 6,000 years old. The compaction of those sediments greatly enhances the relative rise of sea level and threatens that country's major source of agriculture. So this is just setting the stage. I'm going to kind of plow into a couple things in a bit more detail here. But you can tell that this is not going to be just a Navy problem. This is going to be a NOAA problem, a NASA problem, and you'll see all the other federal agencies that are involved. So tackling this thing is going to require that whole of government approach. So coastal resilience, the main topic. So what is resilience? It's the capacity to recover quickly from difficulties or toughness. A few years ago, Admiral Richardson, when he was the Chief of Naval Operations, held a meeting that they have every year. It's called NFOSIS, Navy Flag Officers and Senior Executives. And so he posed a question to the audience, and he wanted to know, should his strategy use the word resilience, or should it say tough? And Admiral Richardson, a pretty cerebral admiral, clearly came down on the side of resilience. Admiral Gortney, who many of you may know, a 4-star admiral, nicknamed Shortney, stood up and he said, "Admiral, I don't think my sailor's gonna know what resilience means. I say tough. And everybody jumped up and cheered, and so tough it was. Nevertheless, resilience in that ability to bounce back is more than just tough, and it requires a great deal of thought. In implementing a resilient approach, like I say at the bottom of the slide there, is not straightforward. It may be incredibly expensive, or in some cases, just impossible to recover from a punch. So we'll see some examples of that as we move along here. And throughout the week, you'll be thinking about, okay, what is the way to achieve a resilient approach to the attack on our coastlines from sea level rise and these other processes that I'll mention. So I want to touch just a little bit on the slow processes. So on the left-hand side, Jakarta is a poster child for subsidence. This is a city of roughly 20-ish million people, a whole bunch. It's sinking at an incredible rate. A couple decades ago, rates of a foot per year, 28 centimeters per year. That's slowed somewhat, but this city, the capital of Indonesia, is going to need to move to avoid completely submerging. Jakarta's not the only one. Southeast Asia happens to have a number of places. Taipei, Manila, Shanghai, Chittagong. The list goes on and on. Karachi in Pakistan. If you total up the populations of those cities, it's well over 100 million people that are directly affected by relative sea level rise, which is compounded by subsidence. So where does that subsidence come from? Well, mostly it comes from the extraction of groundwater. Now, before you get the idea, oh, well, that's a problem elsewhere. On the right-hand side, Lassie looking forlornly at the fire hydrant way up high, that's in Long Beach, California. So in the 30s, before oil was discovered on the Arabian Peninsula, Long Beach was one of the most productive oil-producing areas in the world. The ground there subsided upwards of 30 feet. It's incredible. When you look at old pictures of Long Beach, Venice Beach, places where I hung out a lot when I was a grad student, they were completely covered with oil derricks. You still see a few relics of those things, but it has happened here. The point here is that subsidence, these slow processes, they're occurring, they're much more prevalent on the eastern coast of the United States than the west, but they're affecting all of us. Okay, so you're going to hear more about these slow processes from other people during the week, so I'm going to skip to the things that are more in our swim lane at O&R, and that is looking at extreme events, short duration, high impact, think hurricane. I had a couple things in here that I thought were kind of funny, but after Hurricane Ian, I decided, you know what, I'm going to stick with a serious approach. So what we're looking at here is a complement to the work that the National Weather Service and others have done for years to predict the trajectory and the intensity of hurricanes. We're also going to be interested in really what happens above land, in predicting things like, okay, will this barrier island be breached? There are barrier islands that have been breached multiple times. The Outer Banks up in North Carolina, where is that likely to happen? It's very difficult to predict what happens above land when you have a major storm. So you'll see some of our partners here, the U.S. Geological Survey, Deltaris, a Dutch company that's been it's quasi-government. We've worked with them for nearly 20 years now. And now I want to introduce how we're going to tackle this program. And that is through a program stood up by Congress in 1997 called the National Oceanographic Partnership Program. I'm not going to read everything to you, but the whole idea is to promote interactions between the federal agencies that support ocean sciences, and through those federal agencies and their funding, incorporation of academic institutions, private industry, nonprofits, and anybody else who wants to come to the table. So facilitating those partnerships is number one. I keep cutting out here. Number one on our priority list. And the goals are not always just scientific. Sometimes it's to build up a community, to even start and create a community, to work on projects that are too big for any of the agencies to tackle on their own, or for projects that fall into the seams where, well, it's not exactly in the ONR swim lane, like coastal resilience, maybe not exactly in somebody else's swim lane, but together we have enough combined interest to put some money on that and start solving some problems. So we're leveraging our priorities. ONR has supported the National Oceanographic Partnership Program, or NOP, since its inception. We have funds appropriated by Congress, about $8 million a year, and we use that money in collaboration with other federal agencies and other partners to move the ball forward on any number of projects. We've started over 200 projects since 1997. A typical annual investment total, including ONR's contribution, might be anywhere from $20 to $35 million is about the top that we've hit. NOAA also has appropriated funds, and as I'll describe, NOAA and ONR, through the reauthorization of the NOP program in 2021, now are working together to support a new NOP program office, and you'll hear about that. It's just standing up now as I speak. Alan Leonardi is leading that charge. Many of you know Alan Leonardi, and I hope that he may be here in the audience. So let me tell you a bit more now exactly what we're doing under the National Oceanographic Partnership Program. But first, here is a list of the agencies. If anybody out in the audience notices that I missed one, please let me know. I had a devil of a time finding all these logos. You see the ones that you recognize, the lower left-hand corner, that's the Marine Mammal Commission. So what is a NOP project? Well, it really just requires two of the agencies to get together and say, hey, we want to do this. At the Office of Naval Research, that's Dr. Reggie Beach, the aptly named Dr. Beach, who works with Jeremy Wyrick at NOAA. They are the two co-chairs of the interagency working group that handles the NOP. So you have to have two federal agencies, and then you need to bring together at least two of the three sectors of public, private, and academia. And because we don't want to just do things willy-nilly, of course, we appropriately review what the agencies are intending to do. And that's part of the legislation, so that's why it's up there. So we typically advertise these NOP projects through a funding opportunity announcement. And you will see those, and you're always welcome to respond to them. Okay, so let me dive into really the focus of my talk today here. And that is a new project that we just started up. It's called the Hurricane Coastal Impacts Project. Our goal is to forecast and predict hurricanes and their impacts in the next few years. We got our kickoff with Hurricane Ian. Now I want to emphasize that we're doing research forecasts. We're not intending to replace the National Weather Service and their operational forecast. So this is research, hypothesis-driven research, to understand what are the impacts when water gets above sea level and moves sediment around, perhaps destroys structures, things like that. So the project comprises 10 teams. They're from all over the place, and you'll see that in just a minute. These teams are all working together, sharing data, and you can look at the results of the work to date on a website. Look up nophurricane.sofar.com, and I'll repeat that again a little bit later. But our goals here are really to produce skillful forecasts, or the ability to predict with some skill the impacts on the coast and in particular to initialize models and databases and our ground truth by using remote sensing. So this is one of ONR's main swim lanes, and that is the ability to transport our science anywhere in the world. And the way we do that, particularly in places where we're not typically allowed to go, is via remote sensing. So that's a huge component of this program, is the use of satellite imagery and then measurements extracted from that imagery to initialize models and then to assimilate into models as processes are occurring. So here are all the participants. Those of you in the back may not even be able to see them, but from industry, I mentioned Deltares. From the Netherlands, Capella Space is a small startup with synthetic aperture radars. Seahorse Consulting, Fathom Science, SOFAR Ocean, I'm not going to read them all. Airbus is a big one. They make commercial satellites, Terrace RX, Cosmos SkyMed, if you might be familiar with them. You can see the government agencies down there. We're not picky. We're bringing pretty much everybody on board. And then the academic institutions. There's a whole raft of them, close to 100 participants, including a number of graduate students. So an important component of this program is training the future workforce. And what are we doing here? So we're really focusing on predicting the impacts on land, but of course to do that, you have to have a pretty good idea of what's going on in the water. So while we have improved our forecast of hurricane paths and intensity, particularly things like rapid intensification, there's still a lot of issues trying to predict what's going to happen once you get water up above sea level. Flooding, coastal breaching, property destruction, loss of infrastructure. These are very difficult problems that impact, not just scientists, of course, but whole communities. They drive insurance rates and things like that. So these are very important things to understand if you're going to try to implement a resilient approach to the coastal issues that we face. So the picture there is just a few weeks old. This is from the Navy P-3 flying from the Naval Research Laboratory. They pushed a number of the SOFAR ocean spotter buoys out the door, as well as a number of NOAA buoys. So we worked closely together to look at Hurricane Ian as it approached the Florida coast. So this prediction I already mentioned is difficult. Getting the boundary conditions is hard. You have to measure the elevation of the land surface. Of course, there are multiple ways to do that. One can fly LiDAR and get sub-meter resolution. You can do the same thing, perhaps not quite similar resolution with synthetic aperture radar, and that is available from a number of commercial companies now. We use it a great deal. The other elements include the sediment type. I mean, is it a rocky coastline? Is it sandy? Is it muddy? Is there vegetation? The vegetation can, and that can be either submerged vegetation in the form of seagrass, even things like coral, as well as the terrestrial vegetation. And then, of course, infrastructure in the form of buildings, bridges, culverts, things that are difficult to predict. If those are going to stand up, and if a bunch of trees get knocked down and plug up a culvert, well then the careful calculations of a civil engineer kind of go down the tube. That culvert's not available, and that water's probably going to go over the road that the culvert goes under. So of course we're also addressing the processes, and the number of teams are addressing things like wave and surge impact, sediment transport, one of the most difficult problems in the way that I started at ONR. Three-phase turbulent flow doesn't get much more difficult than that. And then again, the performance of infrastructure, which many communities count on to keep them out of harm's way. Huge pumps in some areas, New Orleans, for example. So the key to the global utility of all these approaches is to try to put together models that can be fed from remote sensing, and I've got an example there of imagery collected by Seastars, so that's, I'm going to screw this up, the Center for Southeastern Tropical Atmosphere Advanced Remote Sensing. University of Miami, Seastars, just remember Seastars. So Seastars is perhaps the premier commercial remote sensing laboratory. They have the ability to get all of the commercial sensors in the US and nearly all of the foreign commercial sensors. I mentioned TerraSAR X from Germany, Cosmos SkyMed. There's many, many assets available now. And these simply were not available 20, 30 years ago. At that time, remote sensing really was the domain of the federal government in our country and in others. Okay, so I want to close up here and leave a little bit of time for questions, but you know, this is not just big government. I talked about ONR, NOAA, NASA, the contributions there, but we've got a small startup, and I want to give a shout out to SOFAR Ocean Technologies. The CEO of SOFAR, Tim Jansen, we supported Tim when he was a postdoc at the Naval Postgraduate School. He's an expert on waves. In fact, built on some of the work of Klaus Hasselmann, the Nobel Prize winner, who many may or may not know, was also one of the founders of understanding surface gravity waves in the ocean. So Tim has done a great job with his company. We brought him on board. When you look at that picture on the left, that's the dashboard of their weather app at SOFAR. You can go ahead and look that up. They have about 850 of these spotter buoys now out over the world's oceans, and through a clever data assimilation technique and some machine learning, they're able to optimize ship routing. And so one of their major products is a package that allows major shipping companies to route their ships in ways to minimize the impact of wind, waves as the ships travel. And therefore saving energy. So in closing, I just want to reinforce the fact that coastal resilience requires a whole of government approach. It's a team sport. We need everybody on board, from the Navy with our particular focus on nearshore processes and short-term processes, to the NOAAs and the NASAs that are focused on longer timescales, and then to the FEMAs, the geological surveys, you name them. We all have to be involved to conquer some of these problems. So I'll stop there and entertain any questions that you might have. Thank you. Yes?
So where would the United States stand? Thank you. My question is, in relation to other countries, the international realm, where does the United States effort in this area of science rank? Are we leading, or are we on par, or is there another country that's actually leading the world?
Well, I think we're pretty dang good. I would hesitate to say that we're leading, but yeah, we probably are. You know, you look at the Dutch, you know, their whole country relies on an understanding of coastal processes. So we've worked very closely with them. You know, we're a lot bigger country than the Netherlands, and we have a great relationship. I would say, you know, most of the European countries have similar capabilities, but I think our ability to pull together teams like this is really unique, particularly to combine the model development. I mean, let me backtrack just a second here. So the NOP program has funded a great deal of model development. HICOM, the Hybrid Coordinate Ocean Model, that was a joint effort between the Navy and the NOAA. That is the Navy's and NOAA's operational model. Those models take decades to put in place. So the development of those models, the ability to make field measurements with cutting-edge instrumentation, we brought it all together in this project here. So I'm gonna back up. I'm gonna say, yeah, we are the best in this, and I want to keep us that way because, as you know, there are other countries in the world that, you know, when it comes to climate change, we all got to work together. But other countries that we butt heads with on occasion, and And they too are developing incredible capabilities to do some of the things that we can do.
Thank you.
Thanks, Admiral.
Hi, Tom. Amanda Nutburn. It's very nice to see you outside of a Zoom box.
Great.
So thank you for the talk. I was wondering if you could comment a little bit more on public-private partnerships. And it's, coming from government, and I've heard this from other science and technology colleagues of mine looking to build out public-private partnership, kind of the challenges we have on the federal side, partnering and, advising and working with the private sector. And, maybe if you could speak to maybe some examples from either the hurricane work or other NOP work as to kind of where that secret sauce is to have successful partnerships there.
Hey, that's a great question, and something that, quite honestly, we've struggled with. Over the years, we've worked at ONR with companies like Shell, Fugro, but the list is kind of short, and we really want to expand that list. And I think the way for that to happen is for us to be much more proactive in approaching companies that we think might be interested, providing funding to small companies. So far is one example where we at ONR have certainly not been the sole supporter of so far. But working on that is really what Congress wants us to do with this reauthorized NOP program. So standing up the NOP office, they will be charged with outreach and pushing on what we've called NOP 2.0. And a huge part of that is establishing connections to private industry and also the philanthropic organizations, which really didn't exist in a big way 20 years ago. But Schmidt, I could name multiple. They all have research vessels. They have cutting edge gear. We have to start working with them.
Okay, I'm Jim Holuska. I'm a longtime Hampton Roads resident, and I've seen hurricanes come and go. And this past one, there was a couple of things that stand out from that. One is down in Florida, there was one town of about 5,000 people that really did a good job of showing resilience to almost a direct hit from a hurricane. It had solar, the lights didn't go off, and the houses were all built to a much higher standard, which I think is going to show how to build federal facilities in the future. And the other was that we had a prediction of a storm surge here that really fell flat. There were schools closed and things like that because they were predicting a 6.5 foot water level. And I was just wondering what happened.
Well, I'm going to leave that question to some of my NOAA colleagues. The models that are used, there's multiple models. They're ensembled together, and of course, there's uncertainty in these models. These are incredibly nonlinear processes. So I'm going to dodge a direct answer to your question, but that's predictions of that nature, the surge. That's what tends to kill people, and so those are the things that we really want to focus on in this work here. I didn't get a chance to show. I showed a picture of a plane and buoys going out the door, but we put in about 20 or so buoys to look in detail at the waves and the winds, which of course, combined with the knowledge of the bathymetry, which we know off the Florida coast, should allow us to do a pretty good job on the surge. Certainly there remain questions to be addressed, but it's a tough problem. So great question though, and emphasizes the need for us to get after some of these things that still plague us. For one more?
One quick one?
Quick, please.
Sure. So NASA is going to orbit in December the Surface Water Ocean Topography mission. that sensor is going to be a real boon to this activity. Do you have plans to incorporate that into what you're doing?
Absolutely. We've been anxiously waiting, SWAT. Thank you.
Dr. Tom Drake, now you know why the fleet loves this guy. What a wonderful job. And speaking up on that whole of government, Tom, I just wanted to give a shout out to the United States Navy, NASA, and NOAA as our 3 federal partners that you will see figuring prominently throughout this entire week. And then tomorrow you're going to see a panel in the afternoon on coastal resilience, and it's led by Old Dominion University. But this is a panel that will be comprised of municipalities, the Hampton Roads Planning District Commission, and the state government. So it's an exciting week for the themes that Tom was talking about and what the sorts of themes that we're trying to present.